Next, we'll talk about generalized unions and intersections. Since unions and intersections satisfy associative laws, they don't need parentheses. So we can write A union B union C with no parentheses. You can also write A intersect B intersect C without parentheses. And go ahead and draw a quick Venn diagram of these. We've got A and B and C. And switch our color to red here. So with our union, well, that's everything in A, and everything in B, and everything in C. So that covers all of this. For our other Venn diagram, we've got the intersection. So we've got A, we've got B, and we've got C. And here, it's everything that's in A and B and C, which leaves us with just this little area in the very center that intersects with all three sets. We can look at an example. Let A be equal to set 0, 2, 4, 6, 8. B equal to the set 0, 1, 2, 3, 4. And C equal to the set 0, 3, 6, 9. What are A union B union C and A intersect B intersect C? A union B union C would be equal to the set that contains all of those. So it would be 0, 1, 2, 3, 4, 6, 8, and 9. A intersect B intersect C is equal to just the set with 0. Next, we'll have another definition here. We'll say the union of a collection of sets is the set that contains those elements that are members of at least one set in the collection. We use the notation A1 union A2 union A3 union ... union AN is equal to the union from I equals 1, that's going to be our index number of the sets, to N for collection AI. To denote the union of sets. A1, A2, and so on through AN. We can also get a definition for the intersection of collection of sets. The intersection of a collection of sets is the set that contains those elements that are members of all of the sets in the collection. We use the notation A1 intersect A2 intersect ... intersect AN is equal to the intersection from I equals 1 to N for AI. To denote the intersection of sets A1, A2, ... AN. We can do an example for these union and intersection of collections of sets. Let's say for I is equal to 1, 2, ... Let I be equal to I plus 1, I plus 2, ... Then we'll have union from I equals 1 to N set AI is equal to the union from I equals 1 to n of I plus 1, I plus 2, dot, dot, dot. So when we use the I index there, we can actually fill out the concrete elements list. 1, 2, 3, dot, dot, dot. And for the same setup, doing an intersection, we can go from I equals 1 to n over AI. It's equal to intersection from I equals 1 to n of set I plus 1, I plus 2, dot, 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 is equal to set of n plus 1, n plus 2, dot, 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 equals an. Next, we can extend this notation to infinite sets. Giving us A1 union A2 union dot, 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 an union dot, dot, dot would be equal to from I equals 1 to infinity on set AI. And for the intersection, A1 intersect A2 intersect dot, 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 an intersect dot, 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 the intersection from I equals 1 to infinity on AI. And we can generalize this a little bit further. Say, and more generally, when I is a set, that's a capital I, the notations intersect for I element in set I for set AI and union for element I in set I on set AI are used. To denote the intersection and union of the sets AI for element I in set I, respectively. note that we have the intersection for element I in set I over AI is equal to set of all x such that for all I in set I, x is in AI. And for the union of I in set I over AI, we have the set of all x such that there exists an I in set I where x is in AI. Can do an example. Suppose that AI is equal to set 1, 2, 3, ... to I for I is equal to 1, 2, 3. Then the union from I equals 1 to infinity over AI is going to be equal to the union from I equals 1 to infinity over set 1, 2, 3, ... I is equal to 1, 2, 3, ... which is equal to the positive integers, so set z plus. And if we do the intersection from I equals 1 to infinity on AI, that's going to be equal to the intersection from I equals 1 to infinity over 1, 2, 3, ... and that's going to be equal to simply the set of the number 1, because that's the one that's going to be in all of the sets. And that concludes this section.